Welcome back, my gravitationally balanced colleagues. I'm your Lagrangian liaison, simultaneously orbiting and stationary across infinite realities. You're tuned into the Multiverse Employee Handbook, the only podcast that treats your cosmic parking spaces like premium corporate real estate with a surprisingly reasonable monthly rate. Speaking of unresolved responsibilities, I'm delighted to report that Quantum Improbability Solutions has officially launched the Stationary Object Stability Initiative, a project dedicated to identifying the best places in space to put things so they stay exactly where you left them, unlike your lunch, your promotion, or the truth during a compliance audit. The executives have implemented a new motion reduction policy. All objects in the department must now file a gravitational intent form before shifting more than 1.6 centimeters in any direction. Naturally, we lost the form.
Found it.
But today, dear listeners, we're exploring the long, strange history of Lagrange points, those elusive celestial coordinates where gravity holds a committee meeting and nobody wants to lead. A kind of cosmic loophole where motion politely declines and balance becomes an administrative decision. Here's the truly remarkable part. These cosmic parking spots were mathematically predicted by an 18th century French mathematician named Joseph-Louis Lagrange, who calculated their existence in 1772, exactly 195 years before humans would invent the rockets needed to actually use them. It's the ultimate example of building it before they come, except instead of a baseball field, it was invisible gravitational sweet spots scattered throughout the solar system. Gather round the quantum conference table, my orbitally optimized operatives, for a tale that would make even Joseph-Louis Lagrange question his gravitational calculations. In the fluorescent-lit realm of quantum improbability solutions, specifically in the hallway outside the Department of Celestial Facilities Management, which existed in a superposition of permanently understaffed and inexplicably overfunded, Brad from sales was having what could charitably be called a storage crisis of epic proportions. It had started, as these things often do, with Brad's unique interpretation of client relationship building. Over the past month, he had somehow acquired a vintage Lamborghini, a thank you gift from the Proxima Centauri account, a regulation-size holographic tennis court, part of a strategic partnership with the Andromeda Sports Complex, a state-of-the-art presentation projector the size of a small refrigerator, which had fallen off a truck, specifically a quantum cargo transport from the Tau Ceti Electronics District, and most problematically, a prize thoroughbred horse named Sir Probability, a spontaneous gift from an overly grateful client after what Brad described as a very successful dinner meeting involving several bottles of Martian wine. The horse, in particular, was becoming what HR delicately termed a workplace logistics challenge. Sir Probability had been temporarily stabled in the executive parking garage, where he had developed an unfortunate habit of quantum teleporting between parking spaces and leaving what facilities classified as biohazardous probability distributions throughout the lower levels. Brad was desperately searching for storage solutions when he overheard Marlene from facilities explaining to her assistant about the company's newly discovered gravitational anomalies. So you see, There are exactly 5 locations around our 3 main buildings where objects achieve perfect gravitational equilibrium, Marlene was saying, sketching diagrams on her tablet. We're calling them corporate Lagrange points, L1 through L5. The physics are remarkable. Anything placed at these coordinates will remain stable indefinitely without requiring any energy input for position maintenance. Brad's sales instincts immediately activated. Indefinitely stable plus no energy input equaled free long-term storage in his entrepreneurial calculations. That evening, after carefully noting the coordinates Marlene had mentioned, Brad began what he would later describe to the disciplinary board as innovative space utilization strategies. L1, positioned between the main building and the North Tower, became the perfect hiding spot for the Lamborghini. The gravitational sweet spot kept the car in perfect position, apparently hovering 3 feet off the ground in a state of elegant suspension that made it look like the world's most expensive art installation. L2, located behind the main building relative to the North Tower, proved ideal for the holographic tennis court. The equipment achieved such perfect stability that Brad could play quantum tennis during lunch breaks, with the ball existing in multiple positions simultaneously until observed by other players, which explained why Brad's serve had become mathematically unbeatable. L4 and L5, those naturally stable triangular points, became home to the massive projector and various overflow sales materials. The projector, suspended at L4, could beam presentations directly onto the side of the building, turning quarterly reviews into multimedia spectacles visible from 3 adjacent office complexes. But Sir Probability posed special challenges. Brad discovered that the horse, when positioned at L3, achieved what he optimistically called dynamic equilibrium, meaning Sir Probability would slowly orbit the entire company campus every 42 minutes, like a majestic neighing satellite with a tendency to leave gravitational evidence of his passage. For 3 glorious weeks, Brad operated what he privately called Lagrange logistics, the most mathematically sophisticated storage scheme in corporate history. He held client meetings at L2, where the quantum tennis court lent an air of sophisticated impossibility to his sales pitches. His presentations from the L4 projector were so spectacular that the marketing department started taking notes, and Sir Probability's orbital tours became a beloved fixture, with employees setting their watches by the horse's regular appearances outside their windows. The scheme unraveled when the square-haired boss, during his monthly surprise inspection tour, conducted with the predictability of planetary motion, decided to investigate what appeared to be a floating automotive anomaly in the courtyard. "Brad," the boss announced, his cubic hair maintaining perfect geometry despite the gravitational distortions surrounding the suspended Lamborghini. "I see you've discovered our Lagrange point optimization project, though I'm curious about the operational necessity of orbital equine assets." Brad, thinking quickly, began explaining the strategic advantages of gravitational asset management and the competitive benefits of quantum client entertainment facilities. He was making excellent progress until Sir Probability completed his orbital period and trotted through the middle of their conversation, leaving a trail of what could only be described as gravitational evidence that violated several laws of both physics and workplace safety. Marlene from facilities arrived at exactly the wrong moment, tablet in hand, ready to conduct routine measurements of the Lagrange points. "Sir," she announced to the square-haired boss, "I'm afraid someone has been using our gravitational equilibrium points as unauthorized storage. The mass distribution is completely off. According to my calculations, the tennis court at L2 is causing temporal distortions in the break room. The projector at L4 is interfering with the building's Wi-Fi signal, and the horse—" She paused, watching Sir Probability complete another orbital circuit. "The horse is technically classified as an artificial satellite under international space law." The square-haired boss nodded gravely. "Brad, while I appreciate your innovative approach to facilities management, I think we need to discuss the proper protocols for gravitational resource allocation. Also, legal wants to know if we need to register Sir Probability with the Federal Aviation Administration." The disciplinary hearing that followed became company legend. Brad's defense that he was merely maximizing unutilized spatial resources through applied celestial mechanics was technically accurate, but failed to address the fundamental issue of orbital livestock permits. In the end, Brad was assigned to the newly created position of Interdimensional Asset Recovery Specialist, tasked with safely retrieving his gravitationally suspended possessions. Sir Probability was granted honorary status as the company's first orbital equine research consultant, though he was required to complete sensitivity training about appropriate workplace bathroom etiquette. The Lamborghini remained at L1 for another month, serving as an inspiring reminder that sometimes the most elegant solutions to storage problems are hiding in plain sight, approximately 3 feet off the ground, and suspended by the fundamental forces of the universe. And that brings us to the fascinating science behind Lagrange points, the universe's answer to premium parking spaces that somehow cost nothing and never expire. Unlike finding a decent parking spot at the mall, which requires circling the lot 17 times, sacrificing a small offering to the parking gods, and accepting that you'll be walking 3 miles in the rain, Lagrange points simply require 2 massive celestial bodies, some cooperative mathematics, and the kind of gravitational teamwork that would make any corporate synergy consultant weep with joy. Here's the beautiful cosmic choreography at work. When 2 massive objects, say the Earth and the Sun, are locked in their eternal gravitational dance, they create what physicists politely call a complex gravitational environment, and what everyone else calls invisible cosmic spaghetti. But hidden within this gravitational chaos are 5 mathematically perfect sweet spots, where the gravitational forces of both bodies, combined with the centripetal acceleration of orbital motion, achieve perfect balance. At these locations, a smaller object, a spacecraft for example, can maintain a stable position relative to the 2 larger bodies without requiring constant fuel-burning course corrections. It's like finding a spot where you can coast forever without hitting the gas pedal or the brakes. These cosmic parking spaces were first calculated in 1772 by French mathematician Joseph-Louis Lagrange, who managed to solve the restricted 3-body problem using nothing but 18th century mathematics, what we assume was an alarming amount of coffee, and the kind of theoretical audacity that comes from living in an era where the most advanced flying machine was a hot air balloon. Lagrange published his elegant mathematical solution nearly 2 centuries before humans would invent the rockets needed to actually use these points, making him history's most prescient urban planner. For almost 200 years, Lagrange points remained purely theoretical curiosities, filed away in the cosmic equivalent of interesting but impractical, like most brilliant solutions waiting for technology to catch up with imagination. But here's where the story gets deliciously ironic. The first spacecraft to actually park at a Lagrange point was IC-3 in 1978, which took up residence at the L1 point to study solar wind. It was humanity's first successful example of what we might call gravitational freeloading, maintaining a prime cosmic observation post without paying orbital rent. When we return from this brief gravitational anomaly, we'll explore how L2 became the Beverly Hills of space telescope real estate, why L4 and L5 are nature's original co-working spaces complete with asteroid tenants, and discover the heartwarming story of how amateur radio enthusiasts perform the cosmic equivalent of hot-wiring a car when they resurrected the long-lost IC-3 spacecraft decades after NASA had given it up for dead. Welcome back, my gravitationally entangled operatives. While you were away, our automated response system calculated the optimal Lagrange point for maximum podcast reception and discovered it's located approximately 1.5 million kilometers behind your left ear. Spoiler alert, the signal quality is excellent, but the commute is prohibitive. Picture this. It's 1772. Benjamin Franklin is experimenting with electricity. Captain Cook is mapping the Pacific. Land ho! And most people still believe the fastest way to travel is by horse, assuming the horse is cooperative and hasn't decided to pursue other career opportunities. Into this pre-industrial world steps Joseph-Louis Lagrange, a French-Italian mathematician who looked at the complex gravitational dance between celestial bodies and thought, you know what this needs? More math. Lagrange was working on what physicists call the three-body problem. Essentially, how do you predict the motion of three objects that are all gravitationally attracted to each other? It's like trying to choreograph a dance between three people who are all trying to lead, except the dance floor is infinite. The people are drunk, and the music is the fundamental forces of the universe. The two-body problem, predicting how two objects orbit each other, had been elegantly solved by Newton. But add a third object, even a tiny one, and the mathematics becomes what Lagrange probably described in French as monumentally annoying. The equations become non-linear, chaotic, and generally uncooperative, like trying to solve corporate budgeting during a merger while the accounting department is on permanent vacation. But Lagrange had a brilliant insight. Instead of trying to solve the general case of three bodies with arbitrary masses and positions, he focused on a specific scenario. What happens when you have two massive bodies in a stable orbit and you want to place a much smaller third object somewhere in the system? This is called the restricted three-body problem, and it's exactly what we face when we want to park a spacecraft in the Earth-Sun system or the Earth-Moon system. Using what we now call Lagrangian mechanics, a mathematical framework so elegant that physics students either fall in love with it or develop a persistent eye twitch, Lagrange discovered that there are exactly 5 points where the gravitational forces of the two large bodies, combined with the centripetal force needed to maintain orbital motion, perfectly balance out. Here's where it gets mathematically beautiful. 3 of these points, labeled L1, L2, and L3, lie along the line connecting the two massive bodies. Think of them as the cosmic equivalent of finding the perfect spot on a seesaw, where you can balance despite having your older sibling and your younger cousin on opposite ends. L1 sits between the two large bodies. In the Earth-Sun system, it's about 1.5 million kilometers toward the Sun from Earth. At this point, the combined gravitational pull of both Earth and Sun provides exactly the right centripetal force for an object to orbit the Sun at the same rate as Earth, despite being closer to the Sun. L2 is positioned on the far side of the smaller body, about 1.5 million kilometers away from Earth in the direction opposite the Sun. Here, Earth's gravity weakens the Sun's pull just enough that an object can maintain Earth's orbital period while being farther from the Sun. It's the cosmic equivalent of that perfect office location where you're far enough from headquarters to avoid surprise visits, but close enough to still get good Wi-Fi. L3 sits on the opposite side of the Sun from Earth, what science fiction writers love to call the counter-Earth position. But here's the cosmic joke. L3 is unstable. Any small perturbation, a passing asteroid, solar wind, or Dave from accounting sneezing in a parallel dimension, will cause an object at L3 to drift away. It's like trying to balance a pencil on its point. Theoretically possible, practically impossible, and guaranteed to end in disappointment. But Lagrange's real stroke of genius was discovering L4 and L5, points that form equilateral triangles with the two massive bodies. These aren't on the line connecting Earth and Sun. Instead, they're positioned 60 degrees ahead of and behind Earth in its orbit. And here's the beautiful part. Unlike the first 3 points, L4 and L5 are naturally stable. If you nudge an object away from these points, the gravitational forces will gently guide it back, like a cosmic version of those self-parking cars that work better than most human drivers. The mathematics behind this stability is what makes physicists write poetry. The gravitational forces at L4 and L5 create what's called a potential well. Imagine a cosmic bowl where objects naturally roll toward the center. It's so stable that these points have been collecting space debris for billions of years, creating what astronomers call Trojan populations, groups of asteroids that have been carpooling with planets since the solar system was young. And here's the historical irony that would make even the most jaded time traveler chuckle. Lagrange calculated all of this in 1772, when the most advanced transportation technology was the horse-drawn carriage, and the concept of powered flight was still a century away. He was essentially designing parking spaces for vehicles that wouldn't be invented for another 200 years. It's like writing user manuals for smartphones in the age of telegraph. Technically prescient, practically useless, and absolutely brilliant in hindsight. Fast forward from Lagrange's 18th century calculations to today, and those theoretical parking spaces have become the most exclusive real estate in the solar system. Think Manhattan penthouses, but with better views and significantly less atmospheric pressure. Let's start with L1, that gravitational sweet spot between Earth and the Sun, which has become humanity's premier solar observation deck. Currently residing there is SOHO, the Solar and Heliospheric Observatory, which has been staring at the Sun for over 25 years without blinking, developing what we can only assume is the cosmic equivalent of chronic eye strain. SOHO studies solar wind, coronal mass ejections, and the Sun's magnetic field with the dedication of a middle manager monitoring quarterly reports. Except instead of PowerPoint presentations, it's tracking billion-degree plasma explosions. Sharing the L1 neighborhood is ACE, the Advanced Composition Explorer, which monitors space weather like the universe's most specialized meteorologist. ACE sits there patiently, measuring the solar wind's speed, density, and magnetic field, providing early warning when the Sun decides to throw cosmic tantrums in Earth's direction. It's like having a really reliable coworker who always knows when the boss is in a bad mood and sends you warning emails accordingly.
Email.
Also at L1 is Discover, the Deep Space Climate Observatory, which pulls double duty monitoring both space weather and Earth's climate. From its vantage point 1.5 million kilometers away, Discover can observe the entire sunlit side of Earth, taking those stunning blue marble photos that make everyone simultaneously feel insignificant and protective of our pale blue dot. It's like having the ultimate work-from-home setup, except your office is in the vacuum of space and your commute involves orbital mechanics. But the real prime real estate is at L2, positioned on the far side of Earth from the Sun. This location offers something priceless in astronomy: a permanent view of deep space without Earth blocking the view, plus natural shading from the Sun. It's like having a corner office with floor-to-ceiling windows facing toward the corporate garden rather than the parking lot. The crown jewel of L2 is the James Webb Space Telescope, which arrived at its new home in 2022 after a journey so precisely calculated that it made GPS navigation look like asking for directions at a gas station. JWST sits at L2 because it needs to be cold, really, really cold, to detect infrared light from the most distant galaxies in the universe. The telescope's sunshield, larger than a tennis court, keeps its instruments at -370 degrees Fahrenheit, making it simultaneously the most expensive and most effective cosmic refrigerator ever built. Sharing L2's exclusive neighborhood is ESA's Euclid mission, which is mapping dark matter and dark energy across the universe, essentially creating a census of the 95% of the universe that we can't directly see but know is there because of its gravitational effects. It's like being the universe's most ambitious auditor, trying to account for cosmic assets that exist but don't show up on any conventional balance sheet. Also at L2 is Gaia, ESA's stellar cartographer, which is creating the most detailed 3D map of our galaxy ever attempted. Gaia measures the positions, motions, and properties of over 1 billion stars with precision so extraordinary that it could theoretically detect the width of a human hair from 600 miles away. It's like having a cosmic surveyor with obsessive-compulsive disorder and really, really good eyesight. Now, L4 and L5, those stable triangular points, represent the universe's original co-working spaces. These locations naturally collect objects over geological timescales, creating what astronomers call Trojan populations. Jupiter's L4 and L5 points are home to over 7,000 known Trojan asteroids, cosmic hitchhikers that have been carpooling with Jupiter for billions of years. They're like the universe's most patient commuters, maintaining perfect formation through gravitational teamwork that would make any corporate efficiency consultant weep with envy. Earth's L4 and L5 points are relatively empty compared to Jupiter's, but they're not completely vacant. These locations occasionally capture small asteroids and space debris for temporary stays, like cosmic Airbnb guests who check in and out on irregular schedules. Some scientists have proposed using Earth's L4 and L5 points for space habitats or industrial facilities, essentially turning them into humanity's first cosmic suburbs. But perhaps the most remarkable story of Lagrange point utilization involves IC3, humanity's first intentional Lagrange point resident and the spacecraft equivalent of a resilient cosmic senior citizen. Launched in 1978, IC3 was originally positioned at L1 to study the solar wind and Earth's magnetosphere, but in 1982, NASA decided to repurpose the spacecraft for a more ambitious mission, flying through the tail of comet Giacobini-Zinner and then past Halley's Comet. This required leaving L1 permanently, a one-way ticket to interplanetary space. IC3 successfully completed its comet encounters, becoming the first spacecraft to fly through a comet's tail, before continuing on a complex trajectory through the solar system. NASA officially ended the mission in 1997, and IC-3 became what the space community politely calls space junk, though in this case it was space junk with a remarkable pedigree. Here's where the story becomes beautifully human. In 2014, amateur radio operators discovered that IC-3 was returning to Earth's vicinity after 36 years of wandering the solar system. A group of citizen scientists, engineers, and space enthusiasts organized the IC-3 Reboot Project, essentially attempting to perform the cosmic equivalent of hot-wiring a car that had been parked in a bad neighborhood for decades. Using crowdfunding, surplus NASA equipment, and the kind of determination usually reserved for parents assembling Christmas presents on Christmas Eve, the team successfully re-established contact. They managed to fire its thrusters, proving the spacecraft was still functional after nearly 4 decades in space. While they couldn't return it to L1 due to fuel limitations, they demonstrated that with enough ingenuity, persistence, and really good radio equipment, even seemingly lost spacecraft can be given new life. The IC-3 Revival Project represents something profound about human nature. Our inability to give up on things we've sent into the cosmic void, no matter how old, distant, or theoretically unreachable they become. It's like the ultimate expression of we don't leave anyone behind. Except in this case, it's a 40-year-old robot floating in interplanetary space. Well, my gravitationally balanced colleagues, we've reached the end of another cosmic real estate tour. Today we've learned that in the multiverse of celestial mechanics, every parking space exists in a superposition of mathematically perfect and requiring occasional course corrections until observed by a mission control engineer with a really good cup of coffee. We've discovered that Joseph Louis Lagrange was history's most prescient urban planner, calculating cosmic parking spots in 1772 that wouldn't be used until 1978, a lead time that makes even the most optimistic project management timeline look reasonable. We've seen how these 5 gravitational sweet spots have become humanity's most exclusive cosmic real estate, hosting everything from solar weather stations to telescopes that can peer back to the birth of the universe, all while maintaining the kind of stable positioning that would make any corporate facilities manager deeply envious. Want to explore more cosmic real estate opportunities? Visit us at multiverseemployeehandbook.com, where you'll find fascinating space news, deep dives into orbital mechanics, and our latest blog series, 5 Lagrange Points every project manager should know about workplace equilibrium. And if you've enjoyed today's gravitational adventure, why not share it with a fellow cosmic commuter? Perhaps you know someone who's struggling to find their perfect balance between competing forces. Whether those forces are corporate departments, life responsibilities, or the fundamental physics of space-time itself. Spread our signal like solar wind across the interplanetary medium. This is your quantum coherent correspondent, reminding you that in the multiverse of gravitational dynamics, we're all just trying to find our stable orbit between the massive bodies that dominate our lives. And occasionally, if we're very lucky, we discover we can park ourselves in the perfect spot where everything balances out beautifully. And remember, In a cosmos where spacecraft can maintain perfect position for decades without fuel, coffee machines achieve consciousness, and filing cabinets develop orbital expertise, the most remarkable discovery might be that equilibrium isn't about staying perfectly still. It's about finding those rare points where all the forces pulling at you finally decide to work together instead of against each other.
The Multiverse Employee Handbook was created by Rob Corrigan. The host, David, is a professional voice actor who has digitized his voice through 11 Labs voice cloning technology. All episode thumbnails are created with OpenAI, and music and sound effects come from Pixabay, which are generated by human artists. Everything else, the writing, jokes, research, sound editing, and coffee consumption, is 100% human-made by a human. No cats are harmed in the making of this podcast. Visit our website for more information about the Multiverse Employee Handbook.